going to be an interesting video. It's got some patents and inventions in it. So this has got some new material in it, okay? So part 199 is line 18j, argon gas, neutrinos, WIMPS DAMA CDMS experiments, 5G Wow Seti. There's the alien radio signal. And the first thing I'm going to do is Google argon gas neutrinos. Now, we did do argon gas earlier. We had the argon gas has come up many times. It's one of the base components that we'll be using for the UFO engine design to get the type of speed that we need to get to Mars or wherever we want to go. Okay, so here are the data links that came up with Fermilab today, which is fnal.gov. They talk about in 2011 a cheaper way to purify liquid argon for neutrino experiments. The purification process begins with argon gas flowing into a tank. So they have an article there. The next thing is symmetry breaking neutrinos from the Symmetry magazine. Again, from December 2011, when neutrinos reach an experiment tank full of liquid argon, the purification process begins with argon gas flowing into a tank. So this was exciting for me because I didn't know anything about these physics and stuff. So when I actually found out that liquid argon is being used with neutrinos, I thought it was really cool. Because my formulas were created before I even found out whether or not they could be used. Basically, that's what came to mind anyways. So search for dark matter in the universe with liquid argon. So that's from neutrino.ethc.ch. If they exist, WIMPs should form a cold thermal relic gas which could be detected. Noble liquid detectors using xenon or argon can efficiently act as targets. And the next thing comes up is WIMPs should form a cold thermal relic gas. So February 1st, 2012 was when I was working on this originally, and it is now April 27th, so it's a couple months later. So my thoughts. WIMPs came up before, and I thought they are now called neutrinos. WIMPs should form a cold thermal relic gas. Let's Google the cold thermal relic gas, and I want to find out what it is. So the ARDM project, a liquid argon TPC for dark matter detection, comes up from iopscience.iop.org. From M. Frenchy. So it says weakly interacting massive particles, which is WIMP, forming a cold thermal relic gas. In the past years, great effort has been put into direct observation of WIMPs, which would. Then the next section talks about dark matter searches with the ARDM detector. Again, WIMPs comes up, cold thermal relic gas comes up, and then we have nuclei, targets, and kinetic. So the next section is New Physics for the 21st Century. It's a Google book from Gordon Fraser, 2006. He talks about cold thermal relic, dark matter particles, cold thermal relic, and sensitive experiments. So February 1st, 2012, my thoughts. Quote, the engine that powers the various kinds of observed active nuclei is black holes with masses ranging from 10 to the power of 6 and 10 to the power of 9 solar masses. Most likely these black holes grew by mergers and the accretion of gas onto high density regions of cold dark matter. The thing is here, the thought that comes to mind is that you need to cool the neutrinos. So we're going to see the picture below from the New Physics for the 21st Century, Volume 10 by Gordon Fraser. This was the book that came up. So there's the picture of it. And here's a little more about his book here. Talks about gamma ray bursts and stuff. And then I do another Google. So what I do is I do a screenshot of what I found. And then he's got WIMP mass. He's got a graph there and everything. Oops. Gotta go over here. So we're going to quotes from Wikipedia. We got keywords, DAMA experiment, CDMS experiment are mentioned in this work here. That's a cryogenic dark matter search there. That's what that is. Okay, we'll go back over here. The DAMA Libra, oops, sorry, I missed something here. Investigations on particle dark matter and other rare processes with highly radio-pure scintillators at Gran Sasso. And that's from people.roma2.infin.it. The DAMA Libra experiment is an experiment designed to detect dark matter using the direct detection technique It is located at the Laboratory Nazionale del Gran Sasso in Italy, and that's the same place they were doing neutrinos as well. The successor to the DAMA experiment, it uses very similar detector technology but has a larger target mass of 250 kg. DAMA Libra has been collecting data since 2003, and first results were reported in 2008. Now this is what I don't understand. It takes you 5 years to do a test, but you do the test in 2003, but then there's nothing reported till 5 years later. I don't understand why it takes so long for them to report stuff. I know why, because they have to let it sit for long periods of time before they can do another test. Yeah, I remember reading that when you do a neutrinos, it's not like a daily test. They do like one once, and then they have to let it sit for a couple months, 3 or 4 months, before they can do the second test. That's why it takes so long. Okay, never mind. So the DAMA Libra setup consists of scintillation, thallium-doped sodium iodide, NEL, radioactively pure crystals. Nuclei recoiling after a collision cause emissions of photons that are detected using photomultiplier tubes. A DAMA Libra setup consists of scintillation. I'm reading it. Okay, detected nuclear recoil can be caused by dark matter particles or by the background thermal neutrons, radioactivity, or cosmic radiation. The revolution of the Earth around the Sun can cause an annual modulation of the dark matter flux. This should give rise to an annual modulation in the detected recoils and thus provide a simple way to extract dark matter signal from the background. The DAMA Libra and the DAMA NEL experiments have used this technique and are the only ones to have reported a positive signal. The results of this experiment are controversial because other searches have not detected nuclear recoils due to dark matter interactions. All these other searches use sophisticated background elimination techniques instead of the annual modulation technique. An independent check of the DAMA Libra signal using the Super Kamiokande neutrino detector is proposed. The signal itself comprised annual modulation of recoil events, frequency in the 2 keV to 6 keV energy band with modulation depth 2% and maximum around 2nd of June. Signal to noise level is high enough to exclude zero modulation hypotheses, although it is unclear if it is enough to rule out solar origin of modulation, because in case of the solar origin, the modulation maximum will be close to the 22nd of June. Independent experiment in the southern hemisphere may prove or disprove an extrasolar origin of the modulation. Early explanations for the DAMA Libra results includes mirror matter because of the unexpected low energy of anomalous recoil events. Recently, some papers suggest that results from DAMA Libra are incompatible with the weakly interacting massive particle WIMP model, so introduction of the Damian concept may be necessary. More conventional explanations using the dark matter concept include an exotic selection of dark matter clustering parameters. Then we have PVLAS, acronym for Polarizzazione di Vuoto con Laser. It's an apparatus dedicated to the detection of dark matter. It is located at the Lugano National Laboratory of National Institute of Nuclear Physics near Padova, Italy. Experiments with the apparatus began in 2001. As dark matter is a form of matter that does not emit or reflect enough electromagnetic radiation to be detected directly, the PVLAS is used to detect the small flattening acquired by a linearly polarized laser beam after it passes through a vacuum space where an intense magnetic field has been applied. More precisely, in the presence of a massive dark matter candidate that interacts with the photon like the axion, the virtual dark matter particles will be preferentially created by photons whose polarization is parallel to the external field. These virtual particles travel slower than the speed of light, and so the effective speed of the photons with a parallel polarization is reduced. Thus the vacuum is birefringent as the index of refraction depends on the polarization. This flattening is characteristic of the propagation of light in a birefringent medium. Notice, however, that uncharged dark matter candidates will not interact with the photon and so will not be detectable by PVLAS. The birefringence of the vacuum of quantum electrodynamics in the presence of an external field is generally credited to Stephen A. Adler, who presented the first general derivation in photon splitting and photon dispersion in a strong magnetic field in 1971. The PVLAS experiment investigates the vacuum after being perturbed by external magnetic fields. So we're going to go on to our next video.